This is my road hopper project. My name is Shariar, and last name is Syed, S-Y-E-D. First things first, you can see we got W-A-S-D. Oops, I actually hit a car. W-A-S-D. You can see the hair likes to move around. A little bit jumpy today, this guy, but here we go. First things first, I can show you, you can see there's a lot of cars moving around, and let's say we have a collision. Oh, there you go. At the top left, you're going to see game over, score 3, and then it automatically restarts the level, which is great. And now I'm going to try to keep going here, and as you can see, it's not that easy. In hindsight, maybe I should have made the game a little bit easier, but I've done it now. So, oops, there we go, whoops. Okay, let's try to get as far as we can. Oops, again. So we've now seen multiple times what it means when you hit a car. Oh, here we go. Got through this part. You can see we've got some scenery. We'll be patient and wait. There we go. We've got a multitude of different cars and they're randomly spawned, thankfully. So that, and there we go. Now we've won the game. It says you win. Your score's 48. And yeah, that is the win and lose logic by the game. Okay, and then the next thing we can focus on is my actual player. So this is the player blueprint right here. This is my player. You can see he's pretty iconic, dressed up in fashion. And so we'll open up my player, and as you can see here, it's a little bit messy, but hopefully I will be able to guide you through it and help you understand what's going on. So number one, the first thing that I want to point is you can see here that I've got a bunch of variables. So tile size right here. So I wanted to take a tile-based approach. I imagine that's how you guys wanted it done. So everything is tile-based. So over here I've got tile size, I've got my start location, I've got my, it's a vector, and I've got my target location, which is also a vector, and then I've got a Boolean that says, okay, is the character moving and what direction is it moving in? And I've got the score, the actual score itself, and then award score to pinpoint, okay, should I actually provide score at all? And the furthest row, and we will get back to the furthest row, but essentially this one just says, okay, what's the furthest the character reached, so that when you go back and you move forward again, you're not given almost double points in a sense. So the idea is you are moving between two different positions, two known positions, the start tile and then the next tile, which is going to be our target location. So as you can see here, this is the input. So when a player comes in and presses one of the movement keys, first things that I do is I set the direction. So over here, for example, back, move one back to the in the y-axis. If I move left, I'm moving in the x-axis. Right is again in the x-axis, but the other way. And then forward right here. And so these are all direction vectors. And then what I do is I use the is it moving? Is the character already moving as a control check? And the reason I do this, and that comes from the B is moving variable. And the reason I do this is because I want the condition on this branch to say, okay, well, is the character already moving? I don't want to move the character if it's already moving, or the actor in Unreal's case. So if the actor is not already moving, then okay, we're all good, we can move. But if the actor is moving, then we want that condition to hold, right? So yeah, this is what over here, you can see this whole section essentially here is just asking, is the player already moving? Well, if it is, then it doesn't matter what the input is, we could just keep moving. But let's say they're not moving. Okay, well, if they are not moving, then we come up here and we say, okay, let's set is moving to true. So this here sets is true. And then we come to the start location and then the target location. And so once the movement is allowed, I get the current location of the actor and put it into the start location, and that's what I set as the start location. And then the target location actually comes from a multitude of calculations. It's, again, remember, because this is a tile-based movement, we're saying, okay, well, if we have the start location right here, and then we have the move direction and the tile size, well, we can say start location plus the move direction times the tile size, so how much the player has moved, comes in, and that added together is actually where we are setting for the target location. So for example, if the tile size is 100 units, which is what I've set, and the player moves forward, I take the current location and then I add a tile in the forward direction because we're moving one forward, right? And so that's what makes the movement kind of tile based, because you're moving one tile every single time. And then we move on to the timeline. And then once the sort of target is set and then we have some movement, we can go over to this timeline, and we don't want to teleport instantly. That was one of the assignment requirements. So to do that, I have a timeline, and my timeline essentially runs from 0 to 0.2 seconds, and it outputs a variable called alpha right here. And alpha over here is just this timer that basically runs from 0 to 1. And it's in a sense like a timer progress value type of thing where it's like, okay, well, if alpha is 0, the player's at the start. And then when alpha is 1, then the player's at the end. And the values in between, kind of the 0 to 1, is a partial progress movement. So over here, you can see I take a lerp vector, and it's because I'm essentially taking two different positions in a 3D space. So over here, we've got our start location and then target location here, and then alpha, which is, again, that value from 0 to 1. So this vector is going to give me some position in that 3D space. So for example, if alpha over here returns 0, it means that we're at the start position. So this lerp vector is going to give us that start position. But if alpha is 0.5, we're about halfway through our movement. And if alpha is 1, then we are pushing to the target location. That's where we want to be. And so that's why I can smoothly kind of animate the player from one tile to the next over that time frame that alpha provides me. And then over here, you can see that I set the new location that comes out of that lerp vector. I can say, okay, well, this is our value, this is what it returned, and this is where we would be in space. So then just put it in as the new location. So on every update of the timeline, it just recalculates the position, and then it just sends it over to the set actor location. And that allows like a almost like a frame by frame movement. That's kind of what I was going for, and I mean it works. So yeah, and then eventually you can see here where that timeline comes in, and once that timeline has kind of finished the sequence and we've moved that frame, I come over here and I just set is moving to false, and I say, okay, well, now the timeline's finished, I can move it over to false, and then the move is complete, and now the player can start another move or do whatever they need to do. So the idea through this whole thing is it takes an input. Oh, gotta come back here. Whoops. So we're gonna take an input and we're gonna check, is it moving? Okay, well, if it's moving, save the start location and the target location, and then we're gonna run the timeline and we're gonna check, okay, well, here we are, here's the timeline, so on and so forth. Where are we at now? And then we use that lerp vector and then we update the position of the player, and then allow that kind of, okay, well, we've done our move, so stop right there, false is good. And yeah, that's how the player movement works. Okay, so the next thing to discuss is how our card movements operate. So this is actually a pairing class that gets inherited by, or in car ambulance, car fast, and car small actually inherit the blueprint for the car itself. So if I'm double click it right here, you can see there's kind of two different things that are going on, and I'll go through each one. But let's start off by talking about how the cars actually move. Well, the cars are off this event tick right here that goes to a sequence, and you can see there's a 0 and a 1, and I'll explain why I've kind of gone down that route. But over here, you can see if we go to 0, it goes to set actor location. Well, how do we know what the actor location, or in this case, the car being the actor, is going to be? Well, it's essentially a formula that I'm using, and the idea is because again, it's a tile-based system, we are going to take our move speed. So this variable right here on the left side, you can see the move speed set to 280, and that's our move speed. And then we're going to take our delta seconds. And the reason we take that delta time is because even if we're in a different frame, we want to make sure that speed stays consistent. So that's why we've taken the delta time. And so what we're doing here is we're going to multiply the move speed by the delta time, and that'll give us, okay, well, this is how fast the car is going to move. And then we multiply all that by the forward vector, so how much it's going to move. And then the new location comes up as we take the location of the car and then we add it to this whole calculation right here. So the formula, in a sense, essentially becomes your new location is dependent on the move speed times the delta time, which is multiplied then by the forward vector, and whatever that result is, you add that to the current location, and that'll give you the new location. And the reason we use a forward vector here and not a regular vector is because we're going to rotate cars, right? So you'll see when you're playing the game, you'll see a lot of rotation. Some cars are rotated 180 degrees, and we want that forward vector to move the 180 degrees. So if its forward vector changes, I don't want it to kind of screw up the calculation. Still want it to work just fine. And the car can drive the opposite way without having any issues. So that's why we stuck to the forward vector in this case. So yeah, that's how the movement works. And if we come back here, this is sort of the destroy logic. And the way that it works is we are going to take the location of the vehicle, or the actor in this case, and because they're moving alongside the x-axis, then we're going to come over here and we're going to take the absolute value, so there's no sense of kind of confusion, and we compare that to our destroy distance variable right here, which you can see I've set to 1600. And then we go through and essentially this over here is a comparable, and we're like, okay, well, what's going on here? And that's our condition, which one is greater in this case. And if the condition returns true, as in the car goes past the limit of the destroy distance, so over here the location says, okay, well, the location is 1601 versus the destroy distance is 1600. Well, this is true. So the moment that happens is we come in and we just call destroy actor, and that way the car has been destroyed. And yeah, that goes across to all of our vehicles. All right, so next up is our spawner logic, but before we go there, I just want to quickly point out each of my spawners, these car spawners, actually has this box around it, and it's a static mesh, and I've called it a spawn check. And you'll see that, for example, if I come over here, you can see it there, see it over here. These manual cars are just because I couldn't get the timing to line up, so there was some conflict, but these manual cars are the only ones that are manual. But everything else is spawned automatically, but you can see another one here, so on. But let's go over here to the blueprint that has our spawn car. So over here, first things first, yeah, naturally we're going to call an event play, and then there's a timer. So the reason the timer runs with the set timer by event, and it loops is because then it ensures, like I've set the timer here for every 2 seconds, we'll have a new car that spawns. Every 2 seconds, we'll have a new car that spawns. So it's essentially like a fixed time interval. And then to determine the car type, so over here I've gotten you can see here it's an array class that references the car types. So we've got our 4 car types: car, ambulance, fast, and small. And so this array comes over here, and then we take a random integer in the range of 0 and 3 because we've got 4 different car types. And then we're just going to pick that random number, and we're going to go, okay, well, this is the class that we want to spawn. And then over here, the other thing that I also did is you have your spawn check. So remember I said this was that kind of barrier at the beginning, and the reason for that is I didn't want cars spawning behind each other consistently. I wanted that the distance essentially to be in such a way where a car steps out of a particular distance before it spawns the next one. So that's why I've got a overlapping actor here. So I've gone, okay, well, here's the spawn check, that box. Is there something in particular within the length of that box over here? And if so, then this is sort of the condition. If there's nothing there, great. Um, Spawn the class or spawn the actor or the car in a sense, right? So yeah, that's essentially the spawn logic for the car. Okay, next up is our score logic, and that score logic is actually called from the player blueprint, excuse me. And the way that it works is number one, you can see here that I've got that variable award score that I discussed earlier. So you can see for the other keys like ASD, there is no award of this awarding score. However, when we go forward, okay, well, this is the point where we actually do want to award the score, right? So we set the award score to be true, but then there's conditions to verify, okay, well, is this the case, and so on. So we come back here and we come to a branch, but the branch conditions actually come from up here. So we get the current location where the actor or the character is, and then we're just going to get the y value. And the reason for that is because the y value tells is where the character is moving, right? It's moving in that axis. So just going to come over here, calculate the y value and then the tile size, and then we're going to compare how far the person has gone. And the way we do that is just the y value plus the size of the tile divide by the tile. And that'll tell us, okay, well, this is the furthest the person has gone. If we take the floor of that value and we compare it to the furthest row integer that we pick up over here, then that becomes our condition. And it says, okay, well, which one is greater? Is the location, the floor of the location of the individual, or the furthest row that we have scored or stored in the furthest row variable? Okay, well, in the case that this condition over here is essentially false, and so what we're saying is, okay, well, where the person is not actually the furthest that they've gotten to thus far. Just go back and just start doing the movement sequence and so on and so forth that I've already discussed in the timeline. But in the event that the person is actually the furthest that they have gotten thus far, we're going to come over here. You can see that I come over here to the condition. Okay, well, in the case that this is true, this condition holds true, furthest row is the greatest number in there. Then we come over here and we actually set that location, the furthest row, to be that location. And then we set the score and we come right back up to our movement branch. And the reason for that is because I noticed when I was doing the scoring calculations, I would go up, for example, a tile, say for example, just move over here. Say for example, I would move to this tile here and then this tile here and I would move back. Well, we're still counting the score because uh, realistically speaking, we have gone back, and then the moment I've gone forward again, well, that's another forward branch movement, right? So this sequence over here would say, oh yeah, no, that's true. This person has moved forward, so just count the score. So that's why I essentially added this branch with this condition up here to double check and say, oh wait, hold on a minute. Have we actually gotten to this point before? Have we? Okay, great. So then don't count the score. If we have gotten further than the point that we were at last, then only count that score because the player can move back and forth. So yeah, that is my scoring logic. Okay, so we now have the win and lose condition. So over here is my character. You can see that the character has a body, a head, and then there's a box, which we'll come back to in a second. But so we open up the player and we say, okay, well, here's the body. And if we have an overlap between the body and a car, well, hold on, that means they touched. So come over here directly to the print string section, right? And now we want to find the score. So we're just going to use a get function, pull out the score, and then it's an integer. We want to convert it to a string, bring it over here to the append section. This stuff, yeah, that's sort of pretty basic. Put that into the string, and then once we realize, okay, well, there's a touch, so on, so forth, and we've gotten the score and everything, all right, just come over here and restart the level, and then we can tell the user game over. Here's the score, right? The other thing that I wanted to point out was the box itself. So if you come over here, the reason I have this box set up around the character is because I was having a lot of trouble with the character actually being able to touch these objects. It was just flying through the 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 objects essentially, or it was just running through the object. So what I ended up doing was I got this box and I built this box and I said, okay, well, if anything comes over, you can see here that, where is my collision? Right here, we've got collision enabled, and it's a custom set, but it just says, okay, block everything, right? But if we click, for example, one of these objects down here, we can come up to collision presets, and it's just a default setting. So now with that, come back here, and with that said, over here's the box. So if the box overlaps anything else, then kind of block that, right? And that's where that comes from, where you could see at the end here, eventually, if that is the true case, it'll stop the person from moving. So I forgot to discuss this earlier, but this sort of applies because the when logic follows a almost a similar fashion, but not exactly the same way. But yeah, that's the box, and down here is the game over logic. Essentially, just follows off that overlap of the body, and when the body touches it. For the win logic, I'm going to come over here to the other side of the map, and you can see I've got this grid in a sense right here. Oops, can I click it? Is it going to let me click it? There we go. Nope, that's a fence. Come on. Yeah, it's essentially a static mesh component with the plane, and it's a what it does here is if we come over and decide. So the idea is pretty simple. The idea is, well, the user comes up and they touch this section right here inside that box, and that gives us the win condition. The way that it does that is I'll open the level blueprint, come over here, there we go. So I've called it the trigger box, and that's the one right at the very end. So if we come back super quick, we can look up trigger, that's what it was called, trigger box right here, and we have that collision component to it, and that's the whole idea where if it touches. So over here, all right, well, who touches the trigger box? Well, the player. So if the player touches the trigger box, then as before with the game over condition, we're just going to pull the score, and on the other side, we're just going to come over here and we're going to say, okay, well, print that string. So it's a very similar logic, and it just says, okay, well, pause the game, and that's it. You can print and say you win, here's your score, you're all good to go. So that is the win logic.